Hello, YouTube. Well, I wanted to make a video to show off my recent project and kind of just give some more detail. I'll give some close-up shots and talk about what went good and what I think I'd like to change. So it's a Barbasol can, obviously, but if you're a Jurassic Park fan, you'll know that the Cryo-Can from Jurassic Park was hidden inside of a Barbasol can, and that's what I have here. So I will take it out. So there's the can, and here's the actual Cryo-Can. It's got a spring-loaded mechanism in it. Kind of tough to do without unscrewing the base, actually. So, oh. Let's see if I can do this. There we go. So, there's the Cryo-Can, and when you twist the base, it pops up. So, all in all, it came out pretty good. I started with some 3D printed models. They're a similar design. I got these off Thingiverse and just 3D printed one first to kind of play with it and get a feel for it and kind of look at how would I manufacture that. And then this one I machined out of 6061 aluminum. Most of it is all custom parts, actually. There's actually very few off-the-shelf pieces. Oh, there's actually an O-ring that goes on the bottom here too. I'll talk about that in a minute. That's one of the things that I want to improve for the next version. This is my first prototype, so there was quite a bit of learning all the tolerances and fit. But really, there's a off-the-shelf O-ring, there's a spring inside of it, and then these vials. So the vials, for anybody interested, they're basically an off-the-shelf 1.5 milliliter micro centrifuge clear vial. I got these initially, which were micro centrifuge vials as well. They're a little different, and so I ended up buying another batch. These come in a pack of 50, and you need 10. But you can see this has like a fold and snap cap, whereas this bigger bag has a screw-on cap. That one's on the floor now. So this one has a screw-on cap, which I think is the more accurate one for the movie. If anybody has any details on things that is maybe not as accurate as it should be in this, let me know. I have a few things that I still want to work on, but all in all, I think it looks really good, and short of somebody really doing a deep dive into all the details, they're not going to be able to tell a difference from the movie one. So let's talk about it. So there's several pieces, and I'll take this one apart and I'll show all the individual pieces, and I'll show you how my mechanism works and and everything. In case anybody wants to try to reproduce it. I know when I was looking at this, I looked at a bunch of pictures, and I didn't really see anybody who had a good video that was a close-up of a working one. And that'll give you guys an opportunity, if any of you guys are Cryo-Can experts out there, to point out, hey, this isn't the most accurate, or this isn't as accurate as it should be. And if you point those out, then maybe I will see if I can incorporate them into my next version. But all in all, I think it came out pretty good. The Barbasol can, this is not the exact right Barbasol can. This is just an old Barbasol can I had. there's a ton of detail out there already about what the exact accurate one is, and there's a issue right here that this is the giveaway for whether it's an accurate can or not. Also, the ounces on the Barbasol can. So I believe the accurate one is supposed to be 11 ounces, not 10 ounces, but I guess making this a square corner gives it a whole extra ounce of internal shaving cream. I'm working on getting one of those. There's a member of the Jurassic Park motor pool who makes more accurate ones. He gets another can that is still the right shape, and then he relabels it with Barbasol. So I'm waiting on that. This one, all I did was I used a can opener, actually, and just put the can opener on there and rolled it around the outside and popped the bottom off. And then the edge was a little beat up, so I took a piece of like round bar, put it on the table, and then kind of rolled it like this to straighten the edge up. It's still a little sharp, so I think I'll sand it some more. The biggest issue that this one has, and that I'm going to change on the next version, is actually I made my tolerances. I made it too good, probably. I made it too close to this diameter. So I was working off of, this is a little tough to measure. It doesn't stay still while you're trying to measure it. And so while it goes in, it's a little too difficult to put it in my opinion. And actually, when it gets down to the bottom, the O-ring's what's supposed to be holding it in, and it's actually too tight. So for me to put it in a can, I have to take the O-ring off. But that's an easy fix. What I'm going to do is I'm going to make this diameter, this diameter, this diameter, and this diameter smaller. And I'll leave the very bottom base the same because that actually matches the can pretty well. Yeah, I mean, let's just dive in. I'll take it apart. I'm going to move the camera and get it close and get some close-ups. I'm not planning on doing any fancy smancy video editing. You guys can see my lab. It's kind of just my basement work area. So, all right, here's the close-up shots. Let's see how we can do this actually. I'm gonna switch sides of the table. That way I can see the camera and show off the parts. My tripod fell over. Okay, so here's the close-ups. So, all in all, I think it turned out pretty dang good. Let's see if I can do that spring action on camera. It's tough to do it. It's weird, like while it's on camera, it's always a pain. So that's locked. And if you twist this, the base springs up. I'll show you why I have to use two hands. You wouldn't normally have to do that, but I have it to where I can disassemble it still. And that means that I'm actually unscrewing it. I need to check in the movie to see. I want to say that he twists it the other way to unlock it. So I might have to mirror my locking mechanism. And then that will, basically when you twist it this way, it will unlock. Right now, you twist it this way and it unlocks. But I'm going to have to go check out the movie for that. So let's take this apart. So this is why when I was doing stuff, it was a little bit trickier. So there's one spring. 2 springs in here. I'm thinking about switching these for just a longer single spring. But this is the base, and there's a threaded hole in here. I believe this is a 3/4 inch thread that I machined. I used a thread milling tool to actually thread mill it. So it's 3/4. It's the correct diameter for a 3/4, but I believe the threads is 20 threads per inch, which is more than a standard thread would be. But that's part of the issue with when I'm unlocking it. I'm actually unscrewing this because I don't have it torqued on tight. And you could put I might put a little Loctite on there or a set screw or something just to stop it from coming apart once it's done, and I don't want it to come apart anymore. So what was happening is when I was twisting this, I was unscrewing the whole mechanism rather than twisting the little spring lock piece. But we'll go piece by piece. So here's the base. It has a dished bottom. I tried to mimic this dish bottom. And actually, I'd like the surface finish to be a little bit better. So I think on the next one, I'm going to do a little bit better. I did this on the CNC mill with interpolated toolpath. And I might even do some laser marking on the bottom to put like an expiration date or something like that on the bottom. And then it's got several, oh, come on, get in focus, there we go. It's got several grooves. And then it's got a large groove that's the O-ring groove. And then, I don't know what I smudged on it. I was probably eating a chocolate cookie or something and got a little chocolate on it. So this was all CNC milled. I believe I held it this way. I machined this. I machined the pocket. I thread milled the inner hole, and I used a grooving tool to put these grooves on. And then I flipped it over, and I had a pair of soft jaws, which is just aluminum vice jaws that have had this shape cut into them. So then I could hold it on this, and then I machined the back, cut it off, and then used a ball end mill to do an interpolated feature there. A little bit slow. This would be probably better on a lathe part, but I'm more comfortable in the CNC mill right now. So that was the easier way to do that. The next part is this heavy base. This is actually not a terribly hard part to make. Very similar operations. I held it, the material down here. I machined the outside shape. I machined the pocket. I put a chamfer. I center drilled all of these holes and drilled them. And then I even came back and countersinked, or I put a little chamfer on the edges here. So this is just a spot drill to give it a little, it's like a dimple. And then these are through holes, and they're actually smaller than the vials. So it's just enough that when it's collapsed, they're in like that. And then when you turn this, it actually uses the vials to turn this upper mechanism. This doesn't connect in any way. It actually just sits on top on kind of the center spindle, and then it can spin around that, and it doesn't do anything. And then if the vials are in there, when you turn it, it actually turns the upper piece. So then we'll continue up. There is this piece, which is actually 2 pieces. Ooh, that's another thing I want to tweak is I made these holes just a tad tight for the vials, which initially I was thinking would be a good thing, because then when the whole thing springs up, the vials kind of don't fly off. But it ended up being a little tighter than I'd like. So on the next batch, I'm going to make these holes just a tad bigger. I'll go one size up on the drill. So this is 2 pieces that's held together with a couple screws. these 3 screws, which I only have 2 in right now actually, because I machined these and then I later changed my design, and so I had to come back and add the holes to this piece, the threaded holes to this piece. So I did those manually, and they're close, but they're not dead on. So obviously the next one I do is going to be CNC machine, so the tolerances on those will be a little bit tighter. I think that also is part of the reason that the vials are so tight, because I think these 2 rings are just skewed enough that when it goes through one and then it goes through the second, it kind of binds up a little bit. Because, you know, on through one, it's, you know, it's enough to hold it there, but it's super easy to take them in and out. So like I said, I machined these 2 pieces, or I machined this piece, and then I started machining this piece, and I realized, wait, these have to be connected together, and I hadn't figured out how I was going to do that. And so what I did is I added these 3 countersunk screws, which they're number 164 screws, Phillips head countersunk. And then I had to add these 3 threaded holes manually. So what I did is I lined these up, and then I used a punch to mark them, and then I drilled and tapped them. And they came out, I mean, it came out good enough for the prototype, right? But it's in the next one I make, this, when I machine this piece, I'll put those holes in with the CNC at the same time. It'll all be one fixture, so that'll make it better. So this is the vial carrier. Again, very similar operations for machining these. I held this, the material below the part. I machined this top, did the hole through it, did this, did the drilled holes, put a chamfer on it, and then I flipped it and I held it by this cylinder to machine this backside. I have to move my hands a little further away from the camera so it doesn't focus. Again, these are just through holes on the outside, these smaller holes. They don't do anything. They're purely cosmetic. These hold the vials. And like I said, I want to make them a little bit bigger, because the other thing I realized is I got to put labels on here. There's like a label maker label that goes on here that says what the embryo is supposed to be. And I think when you do that, this fit's going to be too tight, and it'll peel the label off. So I'm going to open all those up, which that's, you know, trivially easy on the next batch. And then the other thing is, this part I'm a little bit not sure about the geometry, because I've seen some that people made that it was kind of tapered like this, and then these drill holes basically removed material, and so you had this kind of tapered shape with drill holes through it, and it made this kind of really interesting, awkward shape. I've also seen the ones where it's kind of a square shoulder like this. So I don't know what the actual movie one is. The scenes in the movie where you can see this are actually not a lot. It doesn't get a lot of screen time for as cool of a prop as it is. So this one is just a carrier. It slides down on here pretty smooth. There's a little bit of play between them. And then this piece is almost identical, except that it's doesn't have this extra piece, and it has a tang that sticks out in the middle, and then that tang, well, it also has these 3 holes which I already mentioned, so those connect it to this and make this one moving piece. And then that tang matches up with the groove in the center post. So what happens is it's in there, and that's what gives it its movement. And then if you bring it down and twist it, it'll push on that locking piece. So that's a good segue into this piece. Again, very similar part. I did this one on the CNC lathe initially, and then I came back and I used the CNC mill for the secondary op. So I basically held my bar here and then used the lathe tool to profile all this and do these grooves at the end. There's supposed to be a hole here too. I didn't drill that hole because I knew this was a prototype and I wasn't too worried about it yet. But there would be a center drilled hole here too that just makes that have a little bit more detail. So that'll be in the next version. And then I flipped it and I held it like this and I machined the back part with a CNC mill. And I drilled the center hole, 3/8 hole all the way through. Well, not all the way through, down to about here. And then I put it on a rotary axis and I held it like this. And on the secondary op, I did the thread mill here too. So this thread matches this thread. So again, it's a standard diameter thread, but I believe the thread mill I had is not the correct pitch number of threads per inch, but it doesn't matter because I use the same thread mill on both, and then these two pieces just thread together. Of course, it's not easy to do while looking through the camera screen. So then those thread together. Now, it's a little tough to see. You see there's a tiny gap between those because the thread, it needs to have a thread relief. So I thought about putting a thread relief here, but I think I'm going to actually just put a little thread relief here so that when these thread together, it'll actually bottom out and it'll seal. And my original plan with this was to put a little dot of Loctite on here once it's all finished and done, and then this wouldn't come apart unless you want it to come apart, and you could get it apart by just applying some heat on this side. It would break the Loctite and then you could pop it apart. Since everything in here is metal, aluminum, except the vials, and you could just take the vials out before you did that, and the O-ring, you could take the O-ring off, then there wouldn't be any problem with disassembling it. And I probably would use like the low strength Loctite because really it's just got to hold it so when you twist you're not unthreading it. And like I said, I got to check this operation. I might need to move this tang to the other side so that it changes which way it opens and closes the mechanism. But CNC lathe, then CNC mill to do this backside, and then I put it in on the rotary axis and I cut this slot, and then I was going to rotate this to cut this groove, but I actually changed my mind and just did a straight cut. So what I did is I brought the end mill down, cut this, and then I brought the end mill straight over to cut this rather than rotating this. And it's a very subtle difference, but what that does is it means you could make this without the need of a rotary axis. You could just hold this in a vise to do that, which is why I wanted to test that idea out. I figured if anybody was duplicating it, they might not have access to a rotary attachment. And then these are just some springs. So what happens is you assemble these pieces together. This goes in here. Then you put two springs in there. I think my other spring rolled off the table, but two of these springs in here, and that actually gets you your travel. Now, I might look up just basically one longer spring, or I might just put a spacer because you actually don't need the travel from two springs. But in order to assemble this, you need to be able to, even when it's compressed. So this is when it's locked and compressed, you still need something to fill this gap. So if I put in just a plastic spacer, that would take up that gap. But it feels really good with the two springs. That's basically it. on this part, I forgot to mention, so it's 2 ops on this, on a milling machine. I held it and I did the top, and then I flipped it and I faced it off, but there's these rotary grooves. So I made a little fixture. It's basically just got matching pegs that stick out that are threaded. And what you can do is you can take these off. Probably boring. People don't want to see me unscrewing screws. Sorry. And what you can do is you can put this on here. And it's a very snug fit because I didn't want there to be any wobble. So this center boss fits in this center hole, and then these 5 bosses fit in here. And I did every other one, mostly because I knew I wanted to put a flat on here, and so that left me some room to take the flat off. And so what you can do is you can assemble this, and then you can put your bolts through. So I have a washer just to spread out the load, and put that in, and then just tighten these down. They don't need to be super tight, but a little snug. And I did 3. I used 3 of them, but I put enough that you could put 5 in if you really needed to, but I didn't need all 5. And you put those in, and then now you can hold this in a collet to get access to this whole outside. And then the reason there's a flat is so when I put this in the collet, I can run an indicator across here. I can use this to determine where's my starting point. I don't think that's necessary, actually. I mean, I doubt anybody would know the clocking of these grooves to these holes, but I did want to be able to come back to the same position if I needed to. So if I took this off and put it back together, or put it back in a second time, I wanted to be able to get back to the same orientation. And I just did these with a ball end mill. So it came down, made a cut, came back out, and I think I did 3 passes to get the depth. They came out pretty good. There's a little bit of rubbing in there. I think the chips weren't evacuating quite as nice as I'd like. Again, I mean, that's getting pretty nitpicky. As a machinist, or a self-taught machinist, I'm not actually a machinist. I taught myself how to do all this on my own. Trial and error and a lot of failures, a lot of YouTube videos. So thanks to all the other machinists out there who actually share their knowledge. But you can see, I think this is chip rubbing. I think what's happening is the chip is getting cut, and then before it gets thrown out, it rubs on the surface, and it gives it just this little bit marred up surface. I mean, again, you were looking at this super zoomed in from 6-8 inches away. You can't see it. And I'm not sure how I'm going to finish these parts. I don't know if I want to sandblast them or just polish them or what. I need to think about that. I did make a couple of these. So this was my first attempt. And you can see the chatter. So this was the feeds and speeds were not right, and this vibrated as it was cutting, and it creates this cool spiral effect. But cool, but not what I wanted. So then I made a second one, and you can see that the vibrations are definitely better. So my feeds and speeds had improved, but were not there. And then this is straight off of the machine if you get your settings right, and it's really smooth. And then since I had already made these, what I did is I used those as my trial pieces to figure out these and test this stuff. And this, actually, it worked out fine the first time. So I ran this one and assembled everything, and it worked great. And then I reran the code on this one. reran the programs, and it worked great. And then I ran this one. So that's a standard practice that I do a lot when I have multiple operations for the same part, is I will keep any ones that I make in the first operation or subsequent operations that aren't quite as good. And then I just use those as my first trials for the next operations. That way, if I mess anything up, it's a part that's probably scrap anyway. This one you can see as well. I started with 1-inch bar stock, and I took a little bit off. I was wanting to clean this surface up and make it prettier, but because it's just a tiny bit out of round, when it was rotating, it would cut here, and then it would stop cutting, and then it would cut again. So I made this diameter just a tiny bit smaller, and that lets it cut all the way around. And then I tested sandblasting this one. So you can see this has kind of a matter surface to it. So this is kind of more of a brushed look, or straight off the machine. Though I've been handling these parts a lot, and I'm gonna probably give them a quick Scotch brighting or something before I'm done. But this is kind of that sandblasted look, which actually looks pretty good. It gives it a matte gray color. So I don't know if I want the whole thing to be a matte gray, or if I want it to be kind of a shiny gray. So let me know in the comments what you think, if you have a very strong opinion on that. So that's my pile of parts. One thing I will say that's a little frustrating is, this is a bag of 50 of these vials, and that was the smallest I could find, and they're not the right vials. And then this is my bag of 500 vials, so I have a lot extra. So, all right, well, that's my Cryo-Can. Feel free to leave me comments, tell me what you think about it. Thanks. Bye.